Okay, hello. This is me just going through another probability question from a stats paper. This one, June 2019, and it's question 1. And this looks to be like a tree diagram question, actually. So what have we got? Bag A, 1 red marble, 9 green. Bag B, 1 red marble, 4 green. Bag C, 1 red marble, 2 green. Yeah, so we'll get 1 red marble. Sasha's going to take 1 red marble from... Sorry, Sasha's going to take 1 marble from A. If he gets red, he stops choosing. If he gets green, he continues to choose 1 from B. If he gets red, he stops. If he gets green, he goes to bag C. So green for go, red for stop, I guess. Draw a tree diagram to represent this information. So this isn't too bad. Like we're going to have like red and green. This is bag A, and we're going to have 1 in 10 and 9 in 10. Now we only need to branch our branches off green because that's the only situation where he goes on to B. In which case it could be red, where it's a 1 in 5, or it could be green, in which case it's a 4 in 5 chance that he keeps going. And it could be bag C, where red is 1 in 3 and green is 2 in 3, I guess. There we go. Okay, so that's the tree diagram done. Probably quite straightforward. Find a probability that Sasha selects 3 green marbles. Well, 9/10 times 4/5 times 2/3 should do the trick. And then we're just going to get 12 out of 25 for that. That's pretty easy. Part C, find a probability that Sasha selects at least 1 marble of each colour. So whenever I look at least one, I prefer to work out the opposite. Yeah. So the probability of at least 1 of each colour, yeah, is 1 minus the probability that they're both green or both red, because it's the opposite. Yeah. So what do we have with that? And you don't have to do it like this. It's just my preferred way of doing it. Well, we just worked out the probability that sorry, when I say both, I should say all, because both implies there's 2, but they're all green, or they just get a red on the first go. I suppose that's the other thing. So all green is 12 out of 25. We've already worked that out. Plus, red on first is what I should say here, because you can't draw 2 reds, or immediate red. And that's just a 1 in 10. And so if we work out this, 12 out of 25 is like 0.48, 0.58, so this is going to be 0.42. Okay, D. Given that Sasha, right, finally we've got something interesting, some conditional probability, because the rest of this question should be straightforward. Right, the probability, right, of given that they select red, find the probability that he selects it from bag B. Yeah, so I'm trying to write it down in the correct order. That's terribly written. Let's just write that. Right, find the probability he selects it from bag B. So red from bag B, given that it is red. Yeah, well, on tree diagrams, I prefer to just use the formula, yeah, blindly, because I understand what the formula is saying. So we want red in B and, yeah, red. Well, that's really a redundant statement, and really all you need there is red in B. And you want to divide it by the probability that you get a red, yeah? Now the probability that there's red in bag B is 9/10 times 1/5. And the probability that it is red is, well, we could have 1/10, or we could have 9/10 times 1/5, or we could have 9/10 times 4/5 times 1/3. And that gives us our final answer, and it comes to 9 out of 26. Hope that was useful. Keep up the good work. Bye bye.